Welcome Wildcats. Today we're going to be looking at our next unit. So we're going to be starting Unit 10, which is all about logarithmic functions. So of course, to begin, we've got 10.1, which is going to be covering defining and evaluating the most basic logarithmic functions that we have. So let's go ahead and hop right into it. First, I want to take a look at a couple of things that you need to know about logarithmic functions, some traits that they all share. Things that we've talked about before, like domain and range. The domain of a function goes from left to right, so if there is a value that it starts at, I like to start all the way on the left side of the graph and figure out what the furthest left point is, and then figure out what the furthest right point is, and that's your domain. That's all that is. Range is the same thing, but it's bottom to top. So if the graph never stops going to the left, as you're looking for the furthest left point, that's negative infinity. If it never stops going to the right, that's positive infinity. Same thing with range, bottom to top. Most students that I have make domain and range far more complicated than it is. It is very, very simple. How far left, how far right, how far down, how far up. And if it never stops, that's either positive or negative infinity depending upon which direction you're going. Somewhat closely related to domain and range, though, is end behavior. We've talked about it a few times. For this, all you're going to do is look at the left side and right side of the graph. On the far left side of the graph, what x value does it approach? Does it go towards negative infinity, or does it stop? That's how it's related to domain. What's the furthest left that it goes? But more important than just that is, what is the graph doing as it gets closer and closer to that number? Is it approaching a number? Is it approaching y equals negative infinity or positive infinity or 0 or any other number? That's what end behavior is about. What does the graph do at the left and at the right? So take a look at your graph. If it's going to your left, that's right. So if it's going to your left and it's approaching a horizontal asymptote, and that horizontal asymptote is at 0, then as x approaches negative infinity, f of x approaches 0. That's all end behavior is. Again, it's another one that a lot of my students look at and they panic because they haven't seen it a lot. But it is very, very simple, just like domain and range is. Next, x and y intercepts. You guys have been talking about these for years now. The x-intercept is where it crosses the x-axis. The y-intercept is the same thing, but it's where it crosses the y-axis. X is horizontal, y is vertical. Next, horizontal and vertical asymptotes. Now, a horizontal asymptote is a horizontal line that the graph does not cross. But because the line is horizontal, that's going to be y equals, because this is a line that never changes on the y-axis. Same thing with a vertical asymptote. It's going to be a vertical line that the graph never crosses. It gets close to it, but it doesn't cross it. But because it's a vertical line, the x value of this line never changes, so the name of the asymptote is going to be x equals a number. There will be a couple questions on your HRW assignment where it asks you when the graph is positive and when the graph is negative. All it's looking for is a range of numbers. So when you look at your graph, say, okay, it's below the x-axis. The graph is negative from here to here. From this x value to this x value, the graph is negative. Or from this x value to this x value, it's above the y-axis, so it's positive. A lot of people confuse this positive and negative values with increasing or decreasing. If the graph is going up as it moves to the right, which would be this way, if the graph is moving up as it goes to the right, that's increasing. If it's moving down as it goes to the right, that's decreasing. But it doesn't matter where on the y-axis that is. Doesn't matter at all. If it's going up, it's increasing. If it's going down, it's decreasing. But with positive and negative values, is it above the x-axis or below the x-axis? Don't make these harder than they are. They're really much simpler than you guys are making them. So, a logarithm is the inverse of an exponential. So last unit we talked about things that were like a number raised to an exponent that had a variable in it. We called that an exponential function. A logarithm is how you solve a problem with a variable in the exponent. It's the opposite. It's how you undo an exponential function. So the way we look at this and the way we read a logarithm is log with a base. Notice that the base is that little b of a number equals another number. So in this case, the one that I have on the screen, log base b of a equals c. So the base here refers to the same thing as the base of an exponential function. Let's take a look at a couple of more specific examples. Converting from logarithms to exponentials. So, log base b of a equals c. Same example we had on the last slide. You could actually rewrite that as an exponential function by taking the base, b, writing that down as your base, and then raising it to the power that's on the other side, or the power becomes the number that's on the other side of the equal sign. So in this case, the power is c, and that equals a. Now you guys might be a little confused as to what this actually means. Log. What does logarithm mean? Well, using actual numbers, log base 4 of 16 equals 2. So that means 4 to the second power equals 16. So basically, when you see log base 4 of 16, and that's all it says, it doesn't have any equals something, all it's trying to ask you is what power do you raise 4 to in order to get to 16? Since the answer is 2, log base 4 of 16 equals 2. That's really all it's asking. That's really all a logarithm is. What power do I need to raise this base to get to this number? So another example, and a way you might actually see it written, is if you have the exponential equation 3 to the x equals 81, and you needed to solve that, you would rewrite that as a logarithm. You would take log base 3, and since 3 to the x equals 81, it would be log base 3 of 81 equals x. So what are we asking ourselves here? What power do I need to raise 3 to in order to get to 81? Now in this case it's not too bad because it's just 4. 3 to the 4th power equals 81. But if it was some weird number that you were trying to get to, like 76.4, all you would have to do is plug log base 3 of the number, like in this case 76.4, into a calculator. And that would give you whatever power you would have to raise it to, or in this case would solve for x. That's the point of these, and that's what logarithms are designed to do, to help you solve exponential equations where there is a variable in the exponent. So that should be all you need in order to successfully do the 10.1 HRW assignment. Once again, we have been gracious, and it is only 10 problems. You have several days to complete it. If you have any questions, please ask. The math here is not difficult, but sometimes it's kind of hard to wrap your head around what we're doing because logarithms are not something you've seen before. So please, if you have questions, ask. But if you can, take a look at these simple formulas that are on the screen right here, see how they switch back and forth from logarithm to exponential, and that should give you a good start. Good luck, Wildcats.